Today we are going to look at some trig identities, and we are going to talk about how we might use them to solve some problems. We already know some of them, and I'm going to go through them rather quickly. I'm going to want you to pause if you don't have them written down already. The first set are the Pythagorean identities, and we found these when we were examining the unit circle. Here they are. Please pause and write them down. The next set are the reciprocal identities. Here they are. Please pause and write them down. And then finally, we have the quotient identities. Again, please pause and write this down. We're going to look at some new ones today. The first set are the sum and difference identities. Please pause and write this down. And the next set are the negative angle identities. Again, please pause and write this down. I would like for you to see where these identities come from. Take a look at the negative angle identities, and sine of negative of x equals negative sine of x. And this is all true based upon the graph, and we can see that by looking at just one value along here. Here's pi over 2. Here's negative pi over 2. And you can see that sine of negative pi over 2 is going to equal negative sine of pi over 2. Sine of pi over 2 is equal to 1, and therefore sine of negative pi over 2 is equal to negative 1. And you can tell this is going to be true for all the angles looking at your graph because of the symmetric properties of the sine curve. This also, you can also see this negative angle identity when we're looking at cosine of negative x equals cosine of x. If you notice, here's pi, and here is negative pi, and we can tell cosine of negative pi is equal to cosine of pi, and they're both 1, and that's going to continue to be the case for all other angles along that curve as well. We can also see this by looking at the tangent, and notice here is pi over 4, here is negative pi over 4, and tangent of negative pi over 4 is equal to negative tangent of pi over 4. And that's going to continue to be the case for all the different values along the graph. The next one I'd like to take a look at is cosine of a plus b. Now, I'm going to derive this formula. It's nothing that I'm going to make you do, but I want you to know where it comes from. So we're going to take a look and we're going to examine this graph that I've put on here. I have the unit circle, and you will notice I'm going to put some segments in here. I'm going to put one segment there and another segment there. And I've drawn in some angles. The angles that I have are a plus b, because that's the angle I'm looking for, and I put in a negative angle b. Those two angles are congruent. They're both a plus b, and therefore this segment is the same as that segment, because I have two congruent triangles in here. I have this guy, and I have this guy. And they are congruent based upon side angle side, and now I know I have congruent segments. Now, I have the coordinates put for this point z of cosine of a plus b and sine of a plus b, and that's because the cosine is the x-coordinate, sine is the y-coordinate. Similarly, I have cosine of a, sine of a, and down here I have cosine of negative b, sine of negative b, because this is my angle, negative b, and of course this is my point 1, 0. Now, I'm going to make this smaller so that I can get it out of my way. And I'm going to use the fact that those segments are congruent to find the formula for cosine of a plus b. In order to do that, I need to know the distance formula. The distance formula is equal to the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Now the left hand side of my equation is xz, and that's going to use this coordinate, and over here the coordinate 1, 0, and I'm just going to substitute in. So I have cosine of A plus B minus 1 quantity squared plus sine of A plus B minus 0 quantity squared. That is the left-hand side. On the right-hand side, I'm going to use the coordinates for y and w, and I'm going to get the square root of cosine of A minus cosine of negative b, quantity squared, plus sine of A minus sine of negative b, quantity squared. Now, working on the left-hand side and the right-hand side, I'm going to square both sides, and then I'm going to multiply it out. On the left, I'm going to get cosine squared A plus B minus 2 cosine of A plus B plus 1 plus sine squared A plus B. On the right-hand side, I'm going to get cosine squared A minus 2 cosine of A cosine of negative B plus cosine of negative b squared plus sine of A squared minus 2 sine of A sine of negative b plus sine squared of negative b. Now, I'm going to use the negative angle identities to simplify this a little bit. So we know that cosine of negative b is equal to just cosine of b, so I'm going to change it to that. And do the same thing here as well. And sine of negative b is equal to negative sine of b. I'm going to change that to positive, and that's going to change that. And sine squared of b, that gets to go to a positive, and when I make it a negative sign, it's going to get squared, and it's going to be positive again. Now, again, these are both equal, and I'm noticing I have some Pythagorean identities in here. Cosine squared of a plus b plus sine squared of a plus b is just 1. And I'm going to simplify on the left side. That's going to give me 1 plus 1, or 2. So 2. And then I still have the negative cosine of a plus b. And somehow I have a plus sign in here. I don't want it to be there. So this will be negative 2 cosine of a plus b. On the right-hand side, I also have some Pythagorean identities. I have cosine of a, cosine squared of a plus sine squared of a, that's 1. And I also have cosine squared of b plus sine squared of b, and that's another 1. So from those, I'm going to get 2. I'm going to have minus 2 cosine of a, cosine of b, plus 2 sine of a, sine of b. And now I am going to subtract 2 from both sides, so those go away. And then I'm going to divide both sides by negative 2. So I have cosine of a plus b equals cosine of a, cosine of b, minus sine of a, sine of b. And voila, there is my Pythagorean identity. Now the rest of the identities, if you're interested, there are a lot of different ones derived on the internet, and I'm going to leave it to you to look those up, or you can ask me in class sometime. Now, I want to see how we can use this to solve some problems. Here I see I have sine of A and cosine of B, and A is in quadrant 1, B is in quadrant 3, and I want to find cosine of A plus B. I also want to find sine of A plus B as well. First, let's start with cosine of A plus B. I'm going to use my formula. Cosine of A plus B is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B. Now, I know sine of A. Sine of A is 3/5. It's given. I also know cosine of B. That's negative 5 over 13, also given. So I need to find the sine of b and the cosine of a, and I'm going to do that by drawing my angles. My angle A is in quadrant 1, and I know that the sine of a is 3/5. So my vertical must be 3, my hypotenuse must be 5, and using Pythagorean theorem, I can find that this is 4. And now I'm going to know the cosine of A. Cosine of A is 4/5 because it's adjacent over hypotenuse. I'm also going to draw in my angle B. My angle B is in quadrant 3. And this must be 5 because that's my adjacent, and this is 13. So the opposite using Pythagorean theorem is going to be 12, and it's going to be negative because it's in quadrant 3. So now I can substitute in that the sine of B is negative 12 over 13. And you can simplify this to 16 over 65. Now, I'm next going to find the sine of A plus B. Sine of A plus B, according to my identity, is the sine of A times the cosine of B plus the cosine of A times the sine of B. Now, I have all the information that I need. The sine of A is 3/5. Cosine of B is negative 5/13. Cosine of A is 4/5. Sine of B is negative 12/13. So now again, if I simplify, I get negative 63 over 65. Now, the next part of the question said, in which quadrant does A plus B terminate? So I want to figure that out by looking at whether cosine and sine are positive. You'll notice that cosine of A plus B is positive. That means that it either is in first quadrant or the fourth quadrant. The sine, though, of A plus B is negative. Therefore, sine is negative in the fourth quadrant and also the third quadrant. So A plus B must be in the fourth quadrant. So that is one type of problem that we are going to solve with these identities. The next is finding exact values for trig functions. So we'd like to find sine of pi plus 12, exact values. And remember, we know the exact values on the unit circle for pi over 6, pi over 4, and pi over 3, and pi over 2, and so on. Now, I'm going to write these as pi over 6. I'm going to put them with 12 in the denominators. That's the same as 2 pi over 12. And pi over 4 is the same as 3 pi over 12. And pi over 3 is the same as 4 pi over 12. And again, we'd like to find sine of pi over 12. So if you notice, if I subtract pi over 4, if I subtract pi over 6 from pi over 4, I get pi over 12, and that's exactly what we're looking for. So I'm going to write this as the sine, I don't like how that came out, the sine of pi over 4 minus pi over 6. And I'm going to use my difference identity. This is going to be equal to the sine of pi over 4 times the cosine of pi over 6 minus the cosine of pi over 4 times the sine of pi over 6. And I know these values on my unit circle. The sine of pi over 4 is the root 2 over 2. Cosine of pi over 6 is root 3 over 2 minus cosine of pi over 4, root 2 over 2, and sine of pi over 6 is 1/2. And this is going to simplify to be root 6 minus root 2 all over 4. I'll see you tomorrow in class.